Now that we've seen that as we take I to higher and higher powers, it cycles between 1, I, -1, negative I, then back to 1, I, -1, and negative I want to see if we can tackle some, I guess you could call them trickier problems, and you might see these surface. And they're also kind of fun to do, to realize that you can use this, the fact that the powers of I cycle through these values, you can use this to really, on the back of an envelope, take arbitrarily high powers of I. So let's try, just for fun, let's see what I to the 100th power is. And the realization here is that 100 is a multiple of 4. So you could say that this is the same thing as I to the 4 times 25th power. And this is the same thing, just from our exponent properties, is I to the 4th power raised to the 25th power. Right? If you have something raised to an exponent and then that is raised to an exponent, that's the same thing as multiplying the two exponents. And we know that I to the 4th, that's pretty straightforward. I to the 4th is just 1. I to the 4th is 1, so this is 1. So this is equal to 1 to the 25th power, which is just equal to 1. So once again, we use this kind of cycling ability of I when you take its powers to figure out a very high exponent of I. Now let's say we try something a little bit stranger. Let's try I to the 501st power. Now in this situation, 501, it's not a multiple of 4, so you can't just do that simply. But what you could do is you could write this as a product of two numbers, one that is a multiple, one that is I to a multiple of 4th power, and then one it isn't. And so you could rewrite this. 500 is a multiple of 4. So you could write this as I to the 500th power, times I to the 1st power, right? You have the same base. When you multiply, you can add exponents. So this would be I to the 501st power. And we know that this is the same thing as I to the 500th power is the same thing as I to the 4th power. 4 times what? 4 times 125 is 500. So that's this part right over here. I to the 500th is the same thing as I to the 4th to the 125th power. And then that times I to the 1st power times I to the 1st. Well, I to the 4th is 1. 1 to the 125th power is just going to be 1. This whole thing is 1. And so we are just left with I to the 1st. So this is going to be equal to I. So it seems like a really daunting problem, something that you would have to sit and do all day. But you can use this cycling to realize, look, I to the 500th is just going to be 1. And so I to the 500th 1 is just going to be I times that. So I to any multiple of 4. Let me write this generally. So if you have I to any multiple of 4. So this right over here is, well, we'll just restrict k to be non-negative right now. K is greater than or equal to 0. So if we have I to any multiple of 4 right over here, we are going to get 1. Because this is the same thing as I to the 4th power to the kth power. And that is the same thing as 1 to the kth power, which is clearly equal to 1. And if we have anything else, if we have I to the 4k plus 1 power, I to the 4k plus 2 power, we can then just do this technique right over here. So let's try that with a few more problems, just to make it clear that you can do really, really arbitrarily crazy things. So let's take I to the 7,321st power. Now, we just have to figure out, this is going to be some multiple of 4 plus something else. So to do that, well, you could just look at it by sight, that 7,320 is divisible by 4. You can verify that by hand, and then you have that 1 left over. And so this is going to be I to the 7,320 times I to the 1st power. This is a multiple of 4. This right here is a multiple of 4. And I know that because any 100 is a multiple, any 1,000 is a multiple of 4, any 100 is a multiple of 4, and then 20 is a multiple of 4. And so this right over here will simplify to 1. Sorry, that's not I to the ith power. This is I to the 1st power. 7,321 is 7,320 plus 1. And so this part right over here is going to simplify to 1. And we're just going to be left with I to the 1st power, or just I. Let's do another one. I to the 90, let me try something interesting. I to the 99th, I to the 99th power. So once again, What's the highest multiple of 4 that is less than 99? It is 96. It is 96. So this is the same thing as I to the 96th power times I to the third power, right? If you multiply these, same base, add the exponent, you would get I to the 99th power. I to the 96th power, since this is a multiple of 4, this is I to the 4th, and then that to the 16th power. So that's just 1 to the 16th. So this is just 1. And then you're just left with I to the third power. And you could either remember that I to the third power is equal to, you could just remember that it's equal to negative I. Or if you forget that, you could just say, look, this is the same thing as I squared times I. This is equal to I squared times I. I squared, by definition, is equal to negative 1. So you have negative 1 times I is equal to negative I. Let me do one more just for the fun of it. Let's take I to the 38th power. Well, once again, this is equal to I to the 36th times I squared. I'm doing I to the 36th power since that's the largest multiple 4 that goes into 38. What's left over is this 2. This simplifies to 1, and I'm just left with I squared, which is equal to negative 1.